All right, logic fans, let's keep rocking here. This is video 4.6b, our second video on section 4.6, and we're continuing to unpack the meaning of the existential quantifier. And so we've got these domains of discourse in play, and we're sort of understanding what the existential quantifier means with respect to a particular domain of discourse. So this right here is a domain of discourse. I've introduced one this way before in section 4.4. It's the same thing. So really quickly, the idea is that this indicates that the object A has the property F. This indicates that the object A lacks the property G, and so on across the board, okay? So there's three objects in this domain of discourse, A, B, and C, and there's these 5 property constants. Some students get confused because, like, for example, here, there's Z, H, Z, and this is in terms of X here. Remember, H, X, H, Y, H, Z all express the same property. Okay, so the individual variable doesn't matter there. So we've got a domain of discourse. It's got 3 objects. They're described this way. Okay, and the question is on this domain of discourse, is this sentence true or false? Is this sentence true or false? Is this sentence true or false? Pause now. Okay, hope you've had a chance to pause and really think this through for yourself, but this says that at least one thing in this domain has the property F, and that's true. The object A does. Okay, the others don't, but the object A does. This says at least one thing in the domain of discourse has the property K. Is that true or is that false? That's false. Okay, whoops. Wrong place. Here we go. There we are. All right, this says at least one thing in the domain of discourse has the property H, and that actually turns out to be true. All of them do, but that doesn't matter. At least one thing does. Let's try a couple of others here. All right, try D, E, and F. Are these statements true or false with respect to this domain of discourse? Pause now. Okay, so we're going to go through this, but this says at least one thing is F, and C has the property J. Does C have the property J? It does, so we're all good on that. We need at least one thing to have F. Does at least one thing have F? Yes. So, the statement, you could think about it this way, FA, let's put it this way, FA and JC, that statement is true. Right, because FA is true and JC is true, so both conjuncts are true, therefore the conjunction is true, and so therefore it's true that at least one thing satisfies this statement right here, okay? Namely, the object A does. So this is a true statement, all right? Let's put that down as true. Go ahead and try the next one if you haven't already. We're going to go through it together, but this needs to have at least one thing satisfy this description. All right, so let's get this description here. So if I plug in A here, the whole sentence has to be true. Or if I plug in B here, the whole sentence has to be true. Or if I plug in C here, the whole sentence has to be true. So provided at least one of those with A, B, C in here is true, this whole existentially quantified statement is true. Otherwise, it's false. So let's take a look at this. Is this statement true or false? And it turns out that it's, let's take a look at it. So this is HA, right? Implies JB. HA is true. JB is false. So we've got a false consequent and a true antecedent, and therefore this conditional is false. Of course, we've got to check it for the case of B too and the case of C also, right? But we can see really, really quickly that everything, so A, B, and C has H. So you're always going to have a true antecedent and always have a false consequent. All of these statements are false. Therefore, it's not true that at least one thing satisfies this description in this bag. Okay? So this statement is, in fact, false. All right? Now, this one, hopefully you've had a chance to work on it. If you haven't, I'll give you a little bit of a hint. Evaluate this, and then it's going to be the negation of that, right? So picture it without that pesky leading negation if it bothers you. But with the pesky leading negation, it says nothing is F. That's not true. At least one thing is F, namely the object A. So this statement is in fact false. Again, if we evaluate this statement, right, at least one thing is F, that turns out to be true, right? Because the object A has the property F. So if we negate that, we're just going to get false here. All right, that's how I'm sort of trying to help you out a little bit with that kind of strategy. It's nice when you have this negation out here, actually, because you can just sort of picture it not there and then evaluate accordingly. All right, let's try a couple of others. All right, let's try these two. Pause now and give these two a shot. Same domain of discourse. Are these sentences true or false on this domain of discourse? Okay, hopefully you've got a chance to pause and think it through for yourself, but this says at least one thing satisfies the following description. At least one thing in the domain satisfies this description. It's not F, and that's true. B and C do, but you just needed one, all right, at least one. Now let's take this one nice and slow. Let's look at not the case that JB. So here's the object B, here's the property F. This says that the object B lacks the property J. So this statement, considered all by itself, not JB, is true. Not JB is true, right? It's true that B lacks the property J. So we got a true antecedent. We need at least one thing to have H. Does at least one thing have H? Yep. In fact, all of them do. So we're looking at a true arrow true situation, which evaluates to, if you remember your truth table for conditional, true. All right. Got to have those truth tables down like the back of your hand. All right. Otherwise, this is just going to be way too much going back and forth and onerous on you. All right, let's keep rocking. Let me give you some sentences to translate. So let's work on some translations together. So let's do, X is a whale, X is a mammal, X is a spider, and your object is to translate these sentences into ordinary English with these renderings. So go ahead and pause now and see if you can figure them out for yourself. State them in ordinary English. All right, hope you've had a chance to pause and think these through. I'm going to give myself some space here to work with. So with respect to this one, this is going to say, let's do it this way. In the domain, there exists at least one thing satisfying this description. Right? Here's the description. It's a whale and it's a mammal. One second, I'll pull this up for you. Okay, so that might be how I would translate that sentence, all right? This would be like our official wording. In the domain, there exists at least one thing that satisfies this description. In Santa's bag, there's something like this. It's a whale and it's a mammal, okay? Let's go ahead and try the next one together, which was B. So it's this is still the answer to A here. Give us a little bit more space. This is still the answer to A here, but try to translate B, and you can use A as your template if you like. So B says, in the domain, there exists at least one thing satisfying this description, right? It's a mammal, and it is not a spider, right? So reach into Santa's bag, look through the content long enough, you will find eventually some one thing that's just like this. It's a mammal and it's not a spider, okay? That's what the sentence says. Let's try C together. So this one's a bit of a monster, all right, but it looks like that. Okay, go ahead and give that one a shot, and this is the answer to B, so you can use this as a template if you like. So this says, in the domain, right, there exists at least one thing satisfying this big, horrible, nasty description. Okay? It's a spider, and if it's not a whale, then it's not a mammal. Incidentally, you can imagine trans on this right here. If you use trans on this, you would get if MZ, then WZ, right? So those are kinds of little tricks you can use to help yourself understand it. So some one thing satisfies this description is the idea. It's definitely this way, and it satisfies this conditional statement as well. Okay, so that's the meaning of it. Let's go ahead and try D together. So here's sentence D, and again, it's a big, long, nastier one, and this was our answer to C, so you can use that as a template if you like. What does D mean in ordinary English? Okay, so in ordinary English, this says there's at least one thing in the domain satisfying this description right here. It's this way, right? So in the domain, there's just at least one thing satisfying this description. It is either a whale or a mammal, and it is not a spider. Okay? So that's exactly what that means. So there's at least one thing that satisfies both of these. It's not a spider, and either it's a whale or it's a mammal. Okay? So that's exactly what that type of thing amounts to. Let's go ahead and look at, I believe there was an E here. Yeah, right. So here's E. It's kind of an interesting statement, but go ahead and see if you can unpack what it means in ordinary English. And here's your template from the previous problem. This is E. Okay, so this one says at least one thing in the domain satisfies this description. If it's a spider, then it's a spider. All right, in the domain, they're satisfying this description. If it is a spider, then it is a spider. Okay? Simple as that. That's exactly what that means, which is different than saying, you know, if I'd said this, right, there exists at least one thing that's a spider and a spider. So it's kind of redundant, and you know from your work with syntax and everything that this is going to be logically equivalent to just sy by itself. It would be just like saying that. But, you know, it's not that way when you have the conditional in there. All right, when you have the conditional in there, this is what it means. If it is a spider, then it is a spider. Okay, that's what this is saying. At least one. Pick something. There's at least one thing in Santa's bag that satisfies that. Okay, a conditional statement. It satisfies this conditional description. Okay. All right, so I want to make a point, and I've already kind of made it, but let's make it explicit. And I think one way to make it explicit is to introduce this. So, you know, let's say you've got two property constants, f and g, and then of course you can consider the negations of both. So quadrant A here represents, you know, the idea that something is both f and g. Quadrant B represents the idea that something is f but lacks g. Quadrant C, you lack f but you have g. In quadrant D, you lack f and you lack g. So it's sort of like all logical possibilities with respect to the two properties f and g exhausted. Now consider these two statements, 1 and 2 here, all right? And the question is that I get sometimes, students say, hey Ash, are these two statements the same, by which I understand them to mean, are they logically equivalent? Okay, so looking at this and thinking about that, you know, pause and think about it for a second, but I'm going to press on here. The answer is that these are not logically equivalent at all, okay? This says one here, that at least one thing satisfies, you know, description B here. There's at least one thing in the bag that's this way, right? All 2 says is that nothing is this way, right? So you can articulate domains where, you know, the one statement is true and the other statement is false, all right? And so that's the kind of thing we've been going over in this video and the previous one, all right? So hopefully that helps. Like, you know, you can think about like, okay, this sort of exhausts all the combinations between f and g, and looking at it that way can help you, you know, understand the sense. Nothing is this, so nothing satisfies A, that's 2, right? This one just says at least one thing satisfies B. Maybe something satisfies, you know, D and C too. Who knows, okay? All right, so that's a nice way of thinking about it. Let's move on to video C. Look for 4.6C, where we will continue our investigation of the meaning of the existential quantifier. See you there.